Conic sections, lesson 7.6. So we'll just get started. So in class we talked about obviously graphing conic sections, and so we didn't really do so much exploration because we've pretty much talked about most of these already in previous classes. So I figured we'll just skip this section and we'll go straight on to the information section, where I'm just going to basically review what the different types of conic sections are, what their graphs look like, what their equations look like, and how do I find all the parts. So the first type of conic section we had was a parabola. So a parabola is kind of like a U shape. It's not quite a U because it's kind of a combination between a U and a V. But there are two different forms of this equation. We have y equals a times x minus h squared plus k. And this, in this form, my parabola opens up or down, depending on what a is. If a is positive, greater than 0, then it's going to go up. If a is negative, less than 0, it's going to face downward. Okay. The other option is if x equals a times y minus k squared plus h, that's going to go left to right. And again, if a is positive, we will open to the right. If a is negative, we will open to the left. So that's the equation for a parabola, the standard form of the equation. There are a few things that we need to find. My vertex, if you remember, is whatever my h and k value are. That's my vertex. To find my focus, I look at that a value. The distance from, if we're going left to right, or excuse me, if we're going up and down, the distance for my focus is going to be the value p. Now to get that p, I'm going to look at 1 over 4a. So whatever my value for a is, I multiply that by 4 and then divide it into 1, and that's the distance from the center, or my vertex, to my focus. So I'll show you an example of this pretty soon here, but let me just continue. So if I'm going left to right, if my parabola is going left to right, my focus is affecting the x value, so that'll be h plus p comma k. If it's going up or down, then my focus is going to affect the y value, so this will be k plus p. So that's how you find the focus for a parabola going left to right or up and down. Now the last value is the equation for your directrix. Your directrix is the imaginary line that's affects the parabola. Remember, a parabola is all the points that are the same distance from the focus, a fixed point, to the directrix, a fixed line. So to find that, it's going to be the same exact distance that the focus is away from the vertex, p. So all you have to do to find the equation for the directrix is you just use that p value and subtract it from whichever value for your vertex you're talking about. So if we're going left to right, if our vertex, or if our parabola is facing left to right, then that means that we're going to be intercepting the x-axis. So that's going to be x equal to negative p. If we're going up and down, then that means we're intersecting the y-axis. So that means our equation is going to be equal to y, where y equals negative p. So this will still be the same value. It just depends on which way our graph is facing. So that is information on a parabola. Let's look at an example real quick. Let's say I have, well, I'll get to that example later. I have that set up aside, so we'll get to that example later. Let's go on to an ellipse. So an ellipse. For an ellipse, we have an equation x minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay, so the only difference between this from left to right or up and down is the values of a and b. So if a is bigger than b, then that means we're going to be going left to right. You notice a squared is under x. So if a is the bigger value, then we're going to go left to right, x. If b is the bigger value, then that means we're going to go up and down. B squared is under y squared, so we know that it's going to go up and down because it's the bigger value. Again, our center of our ellipse, just like with the vertex of the parabola, is going to be h comma k. Then the major axis, the distance from one vertex to the other, is going to be 2 times my a value if it's left to right, or 2 times my b value if it's, up or down. The minor axis is just going to be the opposite. So for left to right, we have 2b, and for up and down, we have 2a. So that means that we can find where the ellipse crosses, where its 2 points are that we call the vertices. So if it's left to right, that means you're affecting the x value. So we're going to take our h from our center, and we're going to add and subtract the a value. And our center's y value stays the same. If we're going up or down, we're affecting the k value, my y value of my center, so the h stays the same. And we're going to add and subtract b from k. So those are the vertices. Now the last thing we need to find is the foci. For that, we use letter C. And to find that, we use kind of like a reverse Pythagorean theorem. For left to right or ellipses, we do c squared equal to a squared minus b squared. And the coordinates for that point will be h plus or minus c from the center, comma k. And then if we're going to go, let me move some of this stuff so that we have more room. Okay, so if we're going up and down for my focus, we do c squared equal to b squared minus a squared, because b is our bigger value. And the point that we use to find this, again, I'm affecting my y value here, so this would be h comma k plus or minus c. That's an ellipse. And I feel like we've done a lot of problems with ellipses and hyperbolas, so I'm not going to worry too much about these. So let's just move on to the next, which is a hyperbola. The general form for, the standard form for a hyperbola is x plus or minus h squared over a squared minus y plus or minus k squared over b squared equal to 1. Now this is for a hyperbola that is going left to right. For a hyperbola going up and down, we have y plus or minus k squared over a squared minus x plus or minus h squared. over b squared equal to 1. So the key thing to remember for a hyperbola is whichever value is positive, that's the direction it's going. So here, my x value is positive, and in left up and down, my y value is positive. So I know that it's really easy to find out which direction we're facing. Okay. Again, our center of our hyperbola is going to be my h and my k values. So hk, whatever that is, that's your center of your ellipse. That's not where the ellipse is graphed. That's just right dead in the center between the two hyperbola. I've been saying ellipse, I meant hyperbola. Talking about hyperbola, saying ellipse. Sorry, getting confused here. To find my vertices, again, I use a and my b value. Whatever my a value is, if it's underneath x, if we're going left to right, I'm going to go left to right a units. If I'm going up and down, I would go left to right, or I would go up and down a units. So for left to right, my vertices are going to be h plus or minus a, comma k. Okay, and for up and down, my vertices are going to affect the y value, so it's h, comma k plus or minus a. In fact, they're very similar to an ellipse here. In fact, they're the identical thing. If we're going left to right, we're affecting the h value. Up and down, we're affecting the k value. Now, the other two vertices, I think I forgot to mention those in the ellipse, but it's the same process for the ellipse as it is for the hyperbola. And that's talking about the co-vertices. So the co-vertices are the vertices that you don't see in a hyperbola, but you do see in an ellipse. So the co-vertices are using the b value. So for horizontal hyperbola, we're going to have we're affecting the y value this time, so it'd be h, comma k plus or minus b. And for the up and down, we're affecting the x value, so it'd be h plus or minus b, comma k. So it's just the opposite. It's the same thing, only we switch our a and b and we affect the opposite value, either k or h. And the same thing goes for an ellipse as well. I didn't talk about that, but it works here as well. If I go co-vertices here, my co-vertices are going to be, if I'm going left to right, I'm affecting my y values, so I'd go h, comma k plus or minus b. And for up and down, I'm affecting my x value, so it'd be h plus or minus b, comma k. And I notice here, as I'm going over this, that I am made a mistake in here. That should be a, not b, right there. Okay, so we've got our center, we've got our vertices, we've got our co-vertices. Now the last thing for a hyperbola is the foci. They have foci just like everything else. So in a hyperbola, we found our a. Actually, I'm going to just copy. I'll just go on. So when we know our a squared and our b squared, we want to use that to find our c. Well, it's different than an ellipse where we subtract the values. It actually looks exactly like the Pythagorean theorem. I'm going to do a squared plus b squared equal to c squared. Solving for c squared, whatever value I get, that's my c. And so I'm going to take my HK, if I'm going left to right, if my hyperbola is opening left to right, I'm going to take my HK, and now I'm affecting my x value, so it's h plus or minus c, comma k. If I'm going up or down, I take my HK value, and I'm affecting my y this time, so it's h comma k plus or minus c. Okay? So that's the foci of a hyperbola. Alrighty? Now there's one last thing that we talk about, and that would be circles. So the standard form for a circle is x minus h squared plus y minus k squared equal to r squared. This is a very simplified form of an ellipse. Basically, my a and my b are both 1. Okay? They have the same value. So that means the distance from the center of my ellipse is the same no matter where I go, which is what gives us a circle. So again, the center is HK. But this time, because the distance is the same from one point on my circle to the center of my circle, I just have my radius. So R is your radius of your circle. And that's all you really need to know for a circle in terms of the equation. If you're wanting to graph it, the easiest way to do this is to put it in this form by completing the square, and then square rooting the r squared to get your radius. And then you got your h and your k and your radius, and it's really easy to graph. Now the last thing I want to talk about before I move on to an example is the general form. We briefly mentioned the general form when we started talking about conic sections, but the general form is ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0. Now you're thinking to yourself, that's a lot of letters and numbers, but really we only use a few of them. We very rarely see b, and the only time we see all of these is when we usually rotate things. So the purpose of the general form is if we have it in this form, I can figure out what kind of conic section I have just by looking at this and by using the discriminant. If you remember from Algebra 1 and earlier this year, the discriminant was that value under the square root of the quadratic formula, b squared minus 4ac. So if I take this value and I find it's less than 0, then I know it's going to be an ellipse or a circle. The only time it will be a circle, though, is when a equals c, okay, and b will have to equal 0. So I should put parentheses around the whole thing. That's the only time it's a circle. If b squared minus 4ac is equal to 0, we have a parabola. And you guessed it, if it's greater than 0, what will it be? You're right, if you said you will have a hyperbola. So that's the general form. That's basically everything that we have in this section. So let me give you an example. So the question is, what is the equation of the graph below? So what I do is I first look at, well, I have a parabola, so I know I'm either going to be, I know I'm going to have only x squared or only y squared. Since I'm opening upward, I know that I'm going to use the formula y equals a times x minus h squared plus k. That's my form. And you'll remember from earlier in the video that fact. So then I look at, first, what's my h and my k? Where's my vertex? Well, my vertex is right here, and it just so happens to be on the origin, which makes it very convenient for us. So I'm going to substitute in, well, my vertex I know is 0, 0. So anywhere I have hk, I'm going to put 0, 0. So I have y equals a times x minus 0 squared plus 0, which makes it really easy for us. So if I simplify this, all I have is y equals a times x squared. Adding 0 doesn't change it. Subtracting 0 from x doesn't change it. So I have y equals ax squared. Now you're telling yourself, what the heck is a? If you remember back to the video, a is what we use to find the distance to my focus and or to my directrix. So if I look here, this is my distance. Actually, let's use a highlighter. So let's see here. This is my, that's not a highlighter, it's a marker. There's a highlighter. This is the distance to the focus, but it's also the same to my directrix. So they're both 1 unit. So that means if I'm using the formula P equals 1 over 4a, I know my P is 1 unit, so I can substitute that in. So I have 1 equals 1 equals 1 over 4a. And if I'm solving for a, all I have to do is multiply by a on both sides. So I get a equal to 1 over 4 because the a is reduced on the right. So that means my a value is 1/4, which means my final equation is y equals 1/4 x squared. So that's an example of taking a graph and getting the equation. Graphing is fairly simple. I think everybody can do it. So let me just show you your multiple choice and free response question here. Here's your multiple choice question. A satellite is launched in a circular orbit around Earth at an altitude of 100 miles above the surface. The diameter of Earth is 7,920 miles. Write an equation for the orbit of the satellite if the center of the orbit is the center of the Earth, labeled at 0, 0. And there's your choices. If you have any questions, please ask in the form, or you can see me or email me beforehand. And there's my cue to say good night. Here's your free response question. Have a good night.